Hello dear students and welcome to my second video about electricity. In this video we will discuss about electroscope, electric current and potential difference. So what is an electroscope? It is a very old and simple device used to detect the presence of electric charge on a body. So if a charge is charged either positive or negative, it shows a certain response to inform us. Then we can study the properties of that very respective charge. In this video, you can see how a simple electroscope can be made at home. So you need two pieces of aluminum foil hanging by a thin copper wire. You can fix them to the jar like the way it is shown here. You can shape the wire through. Now we need an electrostatic charge. So here it is. You can bring the charge object near to the wire. That wire transfers the charge to the aluminum foil and a movement is seen in the foil. Which kind of movement is that? It's the repulsion as seen in the video. It means the charges are of same kind because same charges repel or push one another. The modern electroscope works in the same way. If there is a charge, then the movable conducting rod will move according to the charge. So if there is an increase in the deflection, then the charges are same. If there is a decrease in the deflection, then it means that the charges are of opposite kind. Where do we use electroscope? We use it to show and prove that charges move through the metals. We use to test whether the body is charged or not, or we use it to detect the kind of the charge of the body, so either is it positive or negative. Our next topic is electric current and potential differences, but first we will define what electric current is. We discussed actually before also. We can say that the movement of the electric charges from negative to positive point is called electric current. So the charges are attracted towards the positive end and we provide them with some energy. Also we can say that the flow of electrons is known as the electricity. Now the strength of the electric current depends on the number of electrons passing through the conductor at a point in a given interval. So more the electrons pass through a conductor, the stronger the electric current will be. So if we define electric current according to your book, we can say that the electric current is the rate of flow of electric charges. It is the amount of charge that flows per second. So here is the formula, which is electric current is equals to the charge that moved divided by the time taken. In words, I is equals to Q over T, where I stands for current, Q for the charge and T for the time taken. The SI unit of electric current is ampere, so it is represented by A. These are some of the subdivisions of the amperic values. Electric current is measured with the device called amperemeter. And the effect of the electric current are heating, lightning, and magnetic effects. So electric current can cause heat, lightning, and magnetism, which we have observed many times if we touch a wire or if we see the bulbing. The last topic of this video is the potential difference. Potential difference is the difference in the amount of energy that carries electrons from one point of a conductor to the other point, which means there is a difference between these electrons that makes the electric current flow through the conductor. The potential difference is also known as voltage, and the unit of potential difference is volt. It is measured by voltmeter. The sources of potential difference are electric cells, generators, and batteries. Now, cells are the devices, the chemical devices where current is produced as a result of various chemical changes happening inside the cell body. So chemical energy is converted into electrical energy in a cell. There are two types of cells. There is a primary cell which can be used only one time, like the cell in the watch or clock, or in the remote controls. The cells that can be recharged and can be used again and again are called the secondary cells, like the one in the car batteries.